Okay, so today we are looking at odd and even functions.
Wait, is it as of tomorrow that we're just online learning?
Well, you're online learning right now. As we speak, it's happening. So, yes. Yes. Sorry? I don't mind that either. One of the reasons I don't mind it is because, believe it or not, a typo was found, and I've got to fix it. And yeah, so. Well, yeah, I hate when there's typos in my exams. So. No, the typo was actually in one of the multiple choice questions, where I didn't have a correct answer as one of the options. I know. Look, as a somebody who delights in cruel and unusual punishment, I like it was, and the best part about it is it was question 1. I love that sort of thing, just to rattle you at the start of a test, but it's been discovered, and I'll be fixing it, so your test will come out when it does. Look, after all this sort of rigmarole finishes and we're all back and things get back to normal, I don't think it's going to be that you come back and on day 1, here's an assessment task. Certainly, in fact, I wouldn't do that to you. I'll civilly disobey and give you maybe a week, I don't know, some predetermined period of time after we all come back and we're back in the swing to catch up on assessment tasks. Okay? But for now, no, the gazetted assessment task will not be happening. Okay, so anyway, getting back, we're looking at odd and even functions. There's a couple of different ways. I'm touching my face and my eyes, as you can see, because I don't care. Actually, I'm touching because I've practiced good hand hygiene, other than my board and my keyboard and my phone and my face. There's nothing else I touch. There's a couple of different ways to look at odd and even functions. So there's an algebraic way, we'll start with that, and then there's a graphical way, and we'll look at that as well. So algebraically, if f of x is equal to f of minus x, then f of x is even.
There's a typo on the board.
Yeah, there is a typo on my board. I just fixed that. Oh, sorry, there's another typo. I'm having a bad day. Okay, if f of x is equal to the negative of f of negative x, then f of x is odd. A function can be one of either even, odd, or neither. You can be neither odd nor even. You can be even or you can be odd. They're the 3 options. Now, I'll speak about what it means for a function to be odd or even geometrically now, and then we'll clean the board, and then we'll get through and have a look at some examples. Okay. So geometrically, or graphically rather, if f of x is symmetrical about the y-axis, then f of x is even. If f of x has, there's a number of different ways to phrase this, has 180-degree rotational symmetry about the origin, then f of x is odd. So I'll speak about what that odd and even symmetries look like, and then we'll get to some examples. Okay, we'll look at some algebraic and some graphical examples together. So I've lost my eraser. So when I speak about a graph having symmetry about the y-axis, then what I'm saying is it's like the y-axis is a mirror. Whatever happens on this side of the y-axis is an exact reflection of what happens on this side. And the easiest example that we know of that is a parabola. Y equals x squared is an example of an even function. Okay, so note the symmetry in the y-axis. Whatever's on this side of the y-axis is a mirror copy of what's on this side and vice versa. This is an example of an even function. An odd function well, a great example of one of them is a cubic curve. So this has got 180-degree rotational symmetry in the origin. What does that mean? That means if I was to come along and sort of hold down that little point there at the origin, and I was to grab any part over here and rotate it around 180 degrees through that point, then it would match up exactly with what's down here. And likewise, if I got any part down here and rotated 180 degrees through this point, it would line up with what's over there. So let me grab another colour and try to illustrate that with an example. If I was to get a straight line through the origin between any part of the curve, okay, if I was to pick this point here and rotate it 180 degrees around the origin, and end up at that point there, you can see it really, really clearly when you look at the function like that. So 180 degree rotation bring me from one point on my curve to the same. And it wouldn't matter what straight line I drew, any straight line through the origin that touched one part of the curve would correspond to another point. So this makes this an example of an odd function. Now, Mr. Obeid, how can I memorise this for exams? What's a really good way? Well, I mean, is there a giveaway here that tells you even function and a giveaway here that tells you odd function? All you need to know is how to draw these graphs. And if you've got a math aid, you don't even know how to draw the graphs. You can just basically use your math aid to draw the graphs for you. Okay. So we can get a graphical picture of what even and odd functions look like from our knowing that x squared gives us an even function, x cubed gives us an odd function. Okay. And we can see what they do. Right, yeah, so that's our introduction. We're going to do another video in just a second where we go through some examples and we look at odd and even functions.